So, we are in solid state physics laboratory of Department of Physics, and again I will show you that magnet, electromagnet, as I showed in earlier class. So, there this I will show how the magnetic field is measured using the Gauss meter. Okay. So, whatever principle I described, so I will try to show in the instrument. So, this, as I told, that when you come in the lab, teaching laboratory, you will see that there is a magnet and there is a probe. Now, probe is put inside the between the pole gap, and there we want to measure the magnetic field. Okay. So, this is the probe is, and this probe is connected with this meter. So, as a whole, this is a Gauss meter. So, now if I apply current, okay, if I apply current, so some 1 ampere current I applied, and now field, we noted down the field, it is 1254. Okay. So, then you increase the field, increase the current to 1.3. Okay. So, then its the field is increasing. Okay. So, current versus magnetic field, magnetic field, we can note down and we can plot, and from that plot basically you can find out the slope. So, that is the calibration of this electromagnet with current. Okay. So, later on I know this for different current, what are the different magnetic field. Later on I will just do the experiment, just removing this probe. Here we can put our sample and we can, applying magnetic field, we can do the experiment applying different current, and for that current what is the magnetic field, from calibration curve one can find out. Okay. So, that way we just use this magnetic field. So, today what I am interested to show you that how this Hall probe works, okay. I have described that, I want to show you in the laboratory. Okay. So, we have many Hall probe, So, this is one Hall probe. Okay. So, let me keep it, I will not disturb that one. So, this Hall probe is connected with this meter, and now as I told, here I cannot disconnect it, but I have another one where I am able to disconnect. Okay. So, this is probe, you know. So, just let me open it. Okay. So, this is probe, and this is meter. Okay. So, this together is, we tell the Hall probe or Gauss meter or Tesla meter. Okay. Now, you see what is there, how we use, just we take out this, just it's shaped. So, something is red, something is there, stripe, red stripe. Now, this is meter, this we connect with this we have to connect, there are some direction to connect it. Okay. So, this connect, and then if I put here, you see, if I switch on, okay, see current is 1.3, current is there. So, it will show the, you see, magnetic field, you see. Okay. It is showing the magnetic field. Okay. So now so how this meter knows this magnetic field, how this meter knows the magnetic field, okay? Just through it information is going through this system. So what is there here, as I described in previous class, that so this is a probe, means it can sense the magnetic field at a place, okay, where we will place it, okay. So its name called Hall probe. This may be in another region. This whatever this 4 electrode we are using, 4 electrode we are using for connection, 2 for current and 2 for Hall voltage. So this we tell generally this electrode, this we tell generally probe, this will tell probe, okay, 4 probe method. It is called 4 probe method. So that is why probably it is also called Hall probe, okay. So now whatever I explained, there must be somewhere here that sample, and there should be 4 connection, there should be 4 connection with the sample, 2 for the current and 2 for measuring the Hall voltage, okay. And that current, we have to apply current to the sample, and so someone has to supply current, and 2 will measure the voltage source. From here this voltage should go somewhere which will measure the voltage or tell about the voltage, okay. So there must be some from meter, as I told, inside meter that is there, okay. One power supply is there, one voltmeter is there, and also electronic circuit for multiplication or division, okay. So this communication between this meter and this sensor, that piece of sample, piece of material. So this wire is basically connecting these two, okay. So this wire should have, so here if I open it, you see, here you see this, there are four electrode, there are 4 electrode, here you can see there are 4 electrode, here you can see, you see. So there are 4 hole, female, this is female type, this is male type, okay. So so that means so there are 4 wires, okay. There are 4 wires coming, and here you can see this some black spot at the end, just you can see some black spot, okay. So that is basically sample, very thin sample, and from that sample there must be 4 connection, okay. So for you I have I had old one, it is broken one, so I will show you that one, okay. So but I have to save it, so I am keeping this way. So I have a broken piece, so destroyed one, so this destroyed one, okay. So actually I think it was broken, okay. So I have one destroyed piece, this is the same as that one, but it is broken old one. So whatever the red strip, this I have taken out, you see this one. Now look at it here, okay, look at it here. You can see here, this is the sample, okay, these are small sample, very thin sample, T has to be very thin, okay, and you can see these 4 wires you can see, okay. So these 4 wires is connected with this sample, 2 along the length and 2 along the width, okay. And thickness direction is this, You see, it is perpendicular, thickness is basically in the perpendicular direction of the stripe. So look at the geometry of the sample. So that means when if you want to measure the magnetic field or if you want to satisfy the Hall condition, Hall effect condition, so this probe has to put in the magnetic field in perpendicular direction, you know. This magnetic field, this stripe, magnetic field has to be perpendicular to this stripe. If it is this way, then it will not work. Now this magnetic field along the width, so it will not satisfy the condition, okay, Hall condition. So magnetic field has to be perpendicular to the stripe. Then it will be perpendicular to the current, okay. So this, to satisfy this condition, so here I was able to show you, this very small sample, you see, very small sample, okay, and these 4 wires coming, okay. It's the wire just is the on PCB it is done, I think this is the PCB, okay. So this metallic wire is there. So this is coming through this and this is connected with this wire, okay. So here you can see these 4 wires, but it is difficult to see, but I can see this, there are 4 wires. Here there are 4 wires. I do not know if you focus, this camera is focused, then you can see these 4 wires probably. Is it possible to show that? I think. Yeah, this is 4 wires, okay. So this is basically these 4 wires inside at the end you can show, okay. Right. So this I can see more or less, but anyway, so this is the same wire, you see, this is the same wire, okay. So what is there? So I showed you there is a very thin sample of this PCB, okay, and on PCB these four metal wires are there, okay, 2 for current, 2 for the voltage, and magnetic field we have to apply along this. So that means probe magnetic field along the pole piece, okay. So that's why probe is perpendicular to this, we put in this way, you know, in this way you have to put, probe has to put this way. If we put this way, then you will not get the field, you see. I think that is the case, it is happening. Oh, it is not connected, so let me, so it was not showing, you see, field, because it is not connected. So now let me connect it, okay. So okay, I have connected it. Now it will show this, you see here how I have put here, okay, 70-20. Now if I change the direction, okay, so perpendicular component is decreasing when it is flat, you see, it's almost, it should be 0, it's almost 0, you know, it's almost 0. If you can adjust properly, it is almost 0. So it is very important for measurement. If you do not know the principle, how it works, you will do mistake, okay. So it has to put perpendicular to the field, then only you will get correct field, okay. So this way you have to put, this way you have to put. So basically generally you can maximize you can slightly change and maximize the field, okay. So then you will say, now I am just making it horizontal, you know, this way, making it horizontal, you see. Then if you adjust, then its the field is 0, its field is 0, okay. So depending on the angle of it, this is just slight change of this angle, slight change of this angle, it will give slight change of the angle from the vertical position, okay. it will change this value. Okay. So, for accurate measurement using this one, condition is this has to be perpendicular to the magnetic field. So, magnetic field direction in this direction. So, you have to put, so that field has to be perpendicular to the probe, means there in that probe that sample is there. So, it should fall on the perpendicularly on the surface of the sample, or it should be parallel to the thickness of the sample. So, how sample is put there, so depending on that you have to put. So, I showed you that this connection of 4 wires, it is in plane. So, this direction, perpendicular direction is the thickness in which direction we have to apply magnetic field, right. So, this way you can measure. Okay. So, current is supplied by this through this wire, some supplier is there inside this meter, and voltage is going, and this it is there is a voltmeter. What is the voltage? It is measuring, and now with that some electronic circuit inside there, that C, constant C is given, okay, by the manufacturer. So, it will multiply with that constant. Okay. So, that constant remain constant if I is constant, right. So, I cannot change I means current I cannot change Ix, because it is given by the box, it is set inside. So, customer or the user, we cannot change that one. Okay. So, that Ix also fixed. So, that sample thickness and type of sample, these are fixed. So, C is constant, C remain constant, and that constant is divided, that V voltage is divided by that constant through the electronics, and whatever the value that is shown here. So, that is basically reading of the magnetic field. Okay. So, I think I showed you it is important. So, here what is there? You have a that generally germanium is used, you have a germanium, and then so other side, yes, germanium. Basically you can see this, okay, you can see, okay, here. So, this 4 wire connection has come, okay, this is going, okay. So, I think this way one should, for proper use of an instrument, one should know the principle of that instrument, how it works. If you do not know, then you cannot use properly, you will do mistake. If you know, then you can use confidently. So, I think that is the thing, Gauss meter or Tesla meter or Hall probe, whatever we tell, that is used for measuring the magnetic field, and it is very, Hall effect is very simple way one can explain, and based on this also it is Hall effect, everyone we know, but from using the Hall effect one device can be used, whole world is using this device, all lab. Okay. So, how this device is designed, fabricated, how to design the device. Okay. So, from here one can learn. Okay. So, that way I try to explain you. It is not only this, for other effect one can think of fabricating the device, design the device, and if one can think this way. Okay. So, I think this magnetic field is very important parameter, external parameter for studying different properties. So, I will in this experimental physics 3, I will demonstrate some experiment in solid state physics laboratory, that is also called condensed matter physics laboratory. So, today I will stop here. Thank you.